In the last class, we wrote our own generator of random numbers, and it was based on simple arithmetic involving uh, multiplication and division and addition. In today's class, we're going to use a random number generator, the NumPy Mersenne twister random number generator, for some example calculations. We're going to look at calculating mathematical constants. We're going to look at calculating integrals. We're going to look at other examples. Our generator of random numbers, as I say, was based on multiplication, addition, and division. And it had some flaws. It had some problems. The numbers obviously aren't truly random, but it had flaws in the pattern of random numbers and the period of random numbers. The NumPy Mersenne twister is a more sophisticated random number generator. It's not based on simply multiplication, division, and addition. Rather, it's based on things like shifting bits, ands and ors. And it has features that are much improved over our random number generator. It passes a lot more tests of randomness, although it too is not perfectly random. So we're going to explore this generator, and we're going to use this generator. So a few words about this Mersenne twister. Sounds like a weird name, sounds like an interesting name. It is based on what we call Mersenne primes. And Mersenne primes date back to the 17th century. So Mersenne primes, prime numbers, are prime numbers that can be written in the form of 2 to the power some other smaller prime minus 1. And so that's this equation here. Now, if you plug in a prime number, any prime number, into this equation, you don't always get another prime number, a Mersenne prime. But many primes are given by this formula, this equation, and they're called Mersenne primes. And the Mersenne twister is just based on a Mersenne prime, a particular Mersenne prime. Now, as I say, the twister's algorithm is different from our random number generator's algorithm. So ours was based on arithmetic, addition, multiplication, division. The Mersenne twister, the twister bit, is really shifting the bits around, doing ands of bit patterns, doing ors of bit patterns, and so on and so forth. So that's how it's quite different. It's based, as I say, on a Mersenne prime. The actual Mersenne prime that gets used is this one here. So 19,937 is a prime number. 2 to the power 19,937 minus 1 is also a prime number. And that particular number is what's used for the Mersenne twister. And it provides a period. It provides a stream of random numbers that is much longer than we will get out of our random number generator. So as I mentioned, we're going to use NumPy random number package that uses this Mersenne twister algorithm. And on this slide, I've just listed some of the random number functions that are available in the NumPy random package. And actually, we're just going to use two of them today. We're going to use one in some examples to generate integers, random integers in some range. And that's this function random underscore integers. And then we're going to use a second one to generate random floating point numbers in some range from 0 to 1. And that's this second function here, ranf. So today's class is really just based on calls to these functions from this NumPy library that will allow us to generate random integers over a range that we want, random floating point numbers over a range that we want. And then we're just going to apply the use of these numbers to several different categories of problems.